Industrial environments operate on the edge of structural failure. They are inherently hostile, constantly shifting landscapes of physical and mechanical risk. Accidents in these spaces originate from two distinct points. The first is the Unsafe act. This occurs when a human operator deliberately violates a protocol, bypasses a safety relay, or ignores standard operating procedure. The second origin point is the unsafe condition. This is a physical environmental hazard, an exposed high-voltage line, a fractured ladder rung, or a chemically slick floor. Spotting a single frayed wire or a missing hard hat requires only basic observation. However, an enterprise-scale operation generates thousands of interacting human acts and physical conditions every hour. Relying on random observation across a massive organization guarantees eventual failure. The architectural solution is a safety management system, or SMS. It is a comprehensive, closed-loop framework designed to predict, isolate, and control risk before an incident is triggered. Workplace safety requires moving past a checklist of hard hats and harnesses. It requires a mathematically rigorous, auditable operational system. Before a safety management system can mitigate a hazard, it must identify it. EHS professionals use tools like job safety analysis documents and historical incident data to map the operational terrain. Once a hazard is mapped, its priority is not determined by an inspector's intuition. It is quantified through a strict mathematical formula. The calculation is precise. Risk level equals the likelihood of an event multiplied by the magnitude of its severity. This is the 3x3 risk matrix, the primary quantitative tool used to process that calculation. The vertical axis represents likelihood, scaled from a low probability of 1 up to a high probability of 3. The horizontal axis plots severity, measuring the physical impact from a low of 1 to a critical 3. Consider a worker on a 15-foot scaffolding equipped with proper guardrails. Because of the engineered fall protection, the likelihood of a fall is a low 1. A 15-foot drop carries a high severity of 3. Multiplying 1 by 3 generates a final risk level of 3, classifying the task as a medium risk. Now evaluate a worker on a 5-foot scaffolding built with 0 fall protection. The absence of guardrails pushes the likelihood of a fall to a maximum 3. A 5-foot fall yields a medium severity of 2. 3 multiplied by 2 generates a final risk level of 6, a high risk. The math reveals a counterintuitive reality. The shorter scaffolding presents a significantly higher operational threat. Quantitative tools like the risk matrix strip human bias from the analysis. They force an organization to allocate limited resources to the highest mathematical threats. With risks numerically ranked, they must be contained on the physical factory floor through localized controls. The first layer of control is universal color coding, functioning as an immediate psychological barrier. The emergency spectrum relies on red to dictate fire equipment and stop commands. Yellow flags caution zones and immediate physical environmental hazards. The compliance spectrum uses green to indicate first aid stations. Blue signals mandatory behavioral requirements, enforcing rules like strict hard hat zones. Moving from visual cues to mechanical limits brings us to the inspection tag. Attached directly to heavy equipment, this physical label records the inspector's name, confirms the machine's current status, and establishes a strictly enforced due date for the next evaluation. If environmental controls fail, the final physical barrier between the worker and the hazard is personal protective equipment. PPE is divided into two strict categories. Respiratory equipment, like self-contained breathing apparatuses, seals internal organs from toxins. Non-respiratory gear, like fall arrest harnesses and safety glasses, deflects external trauma. A safety inspection is the rigorous, routine verification that all these localized physical controls and equipment remain intact on the floor. Replacing a frayed harness or a faded tag only treats the immediate symptoms of risk. It fails to address the underlying organizational root causes that allowed the equipment to degrade. To locate those root causes, the perspective must shift away from the physical equipment and toward the overarching macro system managed by executives. Inspections check the physical space. Safety audits check the rulebook itself. A safety audit is a systematic, exhaustive review of the organization's overarching safety management system. It verifies documentation, policies, and rigid compliance with legal statutes. Internal audits are conducted by in-house safety officers. They allow an organization to self-regulate and recalibrate its own procedures. External audits rely on third-party experts or ISO agencies. This removes internal bias and confirms that the company is strictly adhering to government legislation. Even with perfect documentation, the system contains one highly variable element: human psychology. This is managed through behavior-based safety, or BBS. BBS operates on a closed-loop system. Peer observation on the floor triggers immediate operational feedback, which over time corrects long-term habits. Rather than relying on punitive threats, BBS applies positive reinforcement to safe actions, organically shifting the workplace culture. Safety audits repair the structural rulebook of the corporation, while behavior-based safety rewires the psychological culture of the workforce. Why do corporations invest millions of dollars into architecting these complex safety management systems? The answer is purely economic, correcting a fundamental accounting misunderstanding regarding what an accident actually costs an enterprise. Financial analysts calculate workplace incidents using the iceberg economics model. The visible tip of the iceberg represents direct costs. These are the immediate, highly visible expenses, like hospital bills and worker compensation payouts. The submerged base represents indirect costs. These are the hidden, cascading financial losses triggered the exact moment an incident occurs. This includes total loss of productivity, hours drained by investigations, and the cost of recruiting replacement workers. These hidden, indirect costs operate at a massive multiplier, consistently running 4 to 10 times higher than the initial direct costs. A severe workplace accident halts production, while simultaneously draining an organization's financial reserves through these cascading indirect costs. Modern EHS professionals architect systems that defend human life while securing the foundational economic viability of the entire enterprise.